All right, let's jump right in. Today, we're headed to the incredible landscapes of Costa Rica, where farming is, well, it's a huge challenge. We're talking steep hills, super humid lowlands, not exactly easy stuff. And we're going to see how a new eye in the sky, drones basically, is giving farmers this incredible, almost revolutionary advantage. But before we get into all that, let me ask you something. How in the world can you tell a pineapple is sick before it even looks sick? Before the leaves turn yellow or anything like that. It sounds kind of impossible, right? Well, hang tight because the answer to that question is really the key to this whole story. Okay, so here's what we've got on tap. First, we'll dig into why farming in Costa Rica is so tough. Then, we'll see how drones give this whole new perspective. After that, we get into the cool science of seeing plant health from way up high and check out all the other mapping tricks these drones can do. And finally, we'll wrap up by looking at what this all means for the future of precision farming. Okay, Section 1, Costa Rica's Farming Challenge. So you've got this immense pressure on farmers there. They need to produce more, but with less. And they're doing it in one of the most physically demanding places on Earth to grow things. We're talking super steep slopes and incredibly humid lowlands. And you gotta understand, the stakes here are just massive. We're talking about things like pineapples, coffee, bananas. These aren't just crops. They are the absolute lifeblood of the Costa Rican economy. This stuff gets exported all over the planet. So whether it's a huge pineapple plantation or a coffee farm clinging to a hillside, getting it right is everything. So how do you even begin to manage these massive, tricky farms? Well, the old way was to send a person, a scout, to literally walk the fields. But just imagine trying to check every single plant across 50 hectares. It's just not possible. It's slow, it's expensive, and you're always going to miss things. Now, compare that to a drone. It can map that entire same field in just a couple of hours. I mean, the leap in efficiency is just wow. And that brings us right to the solution. The drone's eye view. This is literally about turning weeks of back-breaking work into just a few hours. And the scale here is just mind-blowing. A drone team with the right gear can survey up to 400 hectares in one day. 400. To put that in perspective, that's like hundreds and hundreds of football fields. There's just no way a person on the ground could ever come close to that. No way. But it's not just about being fast. It's about being incredibly precise. We're talking about topographic accuracy of plus or minus 2 centimeters. That means the drone can map the elevation of any given spot on the farm with insane accuracy. So why does that matter? Well, think about those steep Costa Rican farms. Knowing the exact slope of the land is the difference between designing a drainage system that works perfectly and one that, floods your entire crop. It's a huge deal. All right, now we get to what I think is the coolest part of this whole thing, the science of seeing the invisible. This is where we finally answer that question about the sick pineapple. The secret sauce here is a technology called NDVI that stands for Normalized Difference Vegetation Index. But you don't really need to remember that. What you need to know is that it's a way of measuring how healthy a plant is by looking at light that we as humans can't even see. The drones doing this have these special multispectral sensors that can see way beyond our normal visible spectrum of light. So how does it actually work? Well, think of it this way. A healthy plant that's doing its photosynthesis thing is really hungry for red light. It just soaks it up. But at the same time, it reflects a ton of something called near-infrared light. Now, a plant that's stressed or sick, it does the exact opposite. It starts reflecting more red light and less near-infrared. The drone's fancy sensor picks up on that tiny shift and bam, it can see that a plant is in trouble long before our eyes could ever tell. And this chart really lays it all out, right? A regular camera drone, it just sees what we see, damage that's already happened. But a drone with NDVI, it's like a crystal ball. It can spot stress weeks early before you see any symptoms at all. So the big takeaway here is you're not just reacting to problems anymore. You're actually getting out ahead of them. That's a total game changer. So look, being able to see hidden crop stress is already revolutionary. But the real power comes when you take that health data and you layer it on top of a complete digital map of the farm. Because these drones are not a one-trick pony. Their mapping skills go way beyond just checking on plant health. They're basically an all-in-one farm management tool. For instance, you can combine that NDVI health map with the terrain map. All of a sudden, a farmer can see, oh, look, this patch of stressed-out plants is right in that low-lying area that gets waterlogged. Or, hey, that's where the irrigation line must have broken. It connects the what is happening with the why it's happening. And that digital model is super important for the business side of things too. I mean, having GPS-accurate measurements of your farm is a must-have for everything from getting a loan from the bank to filing for crop insurance or getting those important export certifications. It just gets rid of all the guesswork. And that 3D model is what makes planning so incredibly powerful. Engineers can use these super detailed terrain models to plan out new infrastructure. And in a place like Costa Rica, with all its crazy ravines and slopes, this is a lifesaver for designing things like new roads or irrigation systems that actually work with the land instead of fighting against it. And finally, those super high-res photos let farmers do something that used to be basically impossible. Get a really precise count of their plants, see how dense the crop canopy is, and even get a good estimate of the total biomass. All that data plugs right into their yield projections, so they can plan the harvest, hire the right number of workers, and tell their buyers exactly how much product to expect. It's huge for logistics. So all of this brings us to our final section. We're moving from just gathering a bunch of raw data to making genuinely smarter decisions. This is the future, and it is all about precision. And look, this isn't just magic. It's a really buttoned-up professional process. It all starts with careful mission planning. Then they place these GPS-referenced ground control points to make sure everything's accurate. Then comes the flight itself to capture all the data. And after that, all that info gets processed and analyzed. But the final and most important step is delivering that info to the farmer and helping them interpret it, pointing out the exact spots that need attention right now. So here's the bottom line. What we're really watching here is the dawn of something called precision agriculture. It's all about using incredibly detailed data to put water, fertilizer, whatever you need, exactly where it's needed and only where it's needed. It just makes farming way more efficient, more productive, and in the end, a lot more sustainable. And that leaves us with one last thing to chew on. If this technology lets us map and monitor the health of every single plant on a farm, what does that really mean for the future of food? What kinds of new possibilities does that open up for feeding a growing planet? It's definitely something to think about. Thanks so much for tuning in.